Welcome coders! This video will be a general overview of Blazor, one of the newer features added to the .NET ecosystem. Let's start from the beginning. If we want to define Blazor in not too many words, we can say that Blazor is basically C# on the client side, but technically Blazor is a lot more than that. Blazor is a framework created by Microsoft to build interactive web applications using HTML and C# instead of JavaScript. This means we can write server-side code and client-side code using the same programming language, something that .NET developers couldn't do till now. To achieve this, Blazor uses two architectures, and one of them, probably the most important one, it is based on WebAssembly, that, among many other things, allows us to port any application to be executed in JavaScript on the browser. But before we get too deep into the specifics of Blazor, let's stop for a sec and think on how web development usually works. Usually, our server-side code, which can be our APIs or whatever code is at the backend of our application, is written on a programming language that is typically a server-side language like C#, Java, Node.js, or Go. This is what constitutes our backend. To achieve an attractive experience for the user that is fast and intuitive, the UI of web applications is usually written in some of the most important JavaScript frameworks like React, Angular, or Vue. This is what constitutes our frontend. These frameworks have great benefits and are extremely powerful, but the problem for us .NET developers is that we can't use the same language to write backend and frontend code, so we are forced to learn an additional language to be full stack. There is nothing wrong about it, of course, and I personally think it is very important for any developer to learn as many tools as possible, so their development toolbox is dynamic and flexible. However, the idea of learning a single language and being able to write the whole web application only on that language is quite attractive. This is one of the problems Blazor wants to solve. On this example that you can find on the official Blazor website, you can see how HTML and C# work together on the same file without any issues. The click method of the HTML button invokes the increment_count method, which is a short C# method that contains some logic we would normally write on JavaScript. Blazor allows us to write this in C#. Another thing to note is that we can use the value of the variable current_count that is defined within the C# code block on the HTML code. There are no restrictions in terms of when and how we use C# code in a Blazor page. Let's talk a little bit about the two ways of implementing Blazor and its two main architectures. While both are conceptually different, and we will see why, when it comes to implementing one way or the other, that is, what the developer has to do to choose one or the other, the differences are only in configuration. That is, they are minimal differences that are made once and done. The first option is server-side Blazor, or Blazor on the server side, and the second is client-side Blazor, or Blazor exclusively on the client side. Let's see each one a little bit more in depth. Let's start with server-side Blazor. In this Blazor architecture, on the server side, our Blazor app will run completely on the server, inside an ASP.NET website that in turn runs on the .NET runtime. The first time we navigate from the browser to our Blazor app and see the site's HTML, a WebSocket connection will be established. This connection uses SignalR, which is a Microsoft technology that allows any updates in the UI to be resolved by the server in real time. That is, unlike other client-server technologies, SignalR allows the server to send notifications to the client in real time. This means that every action the user performs in the browser, such as clicking a button, will be sent to the server via SignalR, and if this action results in any changes to the UI, this will be sent back to the client via SignalR as well and applied to the DOM object. The server-side application will remain in memory the entire time, so an instance will be created for each user while interacting with the app. While this may sound a bit complicated, there is nothing special the developer has to do other than a simple configuration for .NET to take care of the rest. Let's now see the client-side Blazor architecture. This architecture might be the most interesting one when choosing Blazor, and there is a good chance that it will also be the most used in the future simply because it uses WebAssembly, which is a technology that is already changing the way we develop web applications. But let's see it in detail. When we compile a Blazor application, like any other .NET application, it generates assemblies, which are nothing more than standard .NET libraries. These libraries are interoperable with any other .NET application, even if they were not created in Blazor. This means that we can reuse them in the future if we need to. Unlike server-side Blazor, these libraries must be executed by the .NET runtime. Now, for our application to be executed in the browser, this .NET runtime must be a particular version of Mono, whose extension is .wasm, which means it has been compiled to WebAssembly. Thanks to this, our application can run entirely on the client side, that is, without the need to install any kind of plugin or extension. It is supported by all modern browsers, and it is expected to be so for many more years. In this architecture, our applications are downloaded completely to the browser, along with any other static files such as images or CSS files. Therefore, all actions the user performs in our Blazor app will now be performed locally in the browser without the need to communicate with the server. This means that our application will be much faster and more responsive. Let's now see some of the advantages of client-side Blazor and some of the advantages of server-side Blazor, just to compare them a bit. In the first case, client-side Blazor doesn't need a server. All it needs is a very basic and generally quite cheap technology that allows hosting static files. Everything else is gonna be in the browser. It isn't necessary to install anything, not even .NET, which is what we would normally do on a server, where we would prepare the server by installing .NET Core or the .NET Framework for our application to run. Another advantage is that it runs on all modern browsers, because WebAssembly has become a standard. From now on, all browsers will support it, and all modern browsers like Google Chrome, Firefox, Brave are already supported. It has great performance, and this is basically thanks to the fact that our application does not have to talk to the server. There is no connection that is made, there are no calls to the server or any data expected from the server. Everything is resolved on the client. And it works offline because the first time we access the app, it is downloaded completely to the browser. Now, let's see the server-side Blazor advantages. Here, the initial download will be smaller because unlike client-side Blazor, it does not have to download the entire application. It just has to download the HTML, CSS, and some scripts. The response time of the application the first time we access it from the browser will be quite good. The application runs on all browsers because it does not require WebAssembly. Now, let's talk for a second about the disadvantages of each of the architectures. On Blazor client side, there is more to download and the initial load time may suffer a bit. Access keys stay in the client, and this is, for me, perhaps the biggest disadvantage so far at the time of recording this video. If we use a key to connect to an app, API, or a database server, these keys must necessarily be stored in the client because everything in our application will be in the client. While they can be encrypted, it is clearly not very secure, at least for now. I'm sure that Microsoft will work on this. Another disadvantage is that it requires WebAssembly, and while this should not be a problem if we start in the future, it is also true that often it is necessary for the application to work on all browsers. The processing power is on the browser, and this means that the technical complexity of the app will depend on the capabilities of the browser. If the application needs to perform complex tasks that require a lot of processing power, then we will not be able to use client-side Blazor. And now let's see disadvantages on Blazor server side. In general, it is more difficult to scale because each client needs to have a connection to the server through SignalR. This architecture can be complicated to scale, although it is partially solved using SignalR services. So it is a problem, but not so much for now. Another disadvantage is that the application cannot run offline. We need a server with .NET Core installed, which means an investment in money to get the server and an investment in time to keep it always up to date. And finally, server-side Blazor is less performant than client-side Blazor. Because of the frequent server-side calls the app needs to make to function properly. Although we can say the app will be slow because ASP.NET Core is quite fast to solve the constant interaction between client and server, we can say it will be a bit slower than a client-side Blazor app. And now, let's see how a Blazor solution looks like. So this is how a Blazor application looks like. As you can see, this is just the default application that is generated with a template in Visual Studio. I haven't done absolutely anything, I haven't written any code, I've just created the new Blazor application, and we have a left bar where we have a home page, and we have the counter that has a button. This button increases the value of the count. This is actually the code we saw in the presentation, and I'm going to show it to you again anyway. And we have as well fetch data, which generates random data and dynamically creates an HTML table. As you can see, there is no postback. The page never refreshes, so this application, as you can see, is no different from any other front-end application created with React, Angular, Vue, or even JavaScript. But let's see the code. Let's see how the solution looks like. Again, this solution is no different from any other .NET solution. We have here the static files, our CSS files, and the icon. We also have some data objects here. We have a class, and we have the weather forecast class, and we have the service that is consumed, as we will see later, by the fetch data page, which generates the random values we saw in the forecast table. In fact, let's see here in the pages folder, we have the fetch data page that I was talking about. As you can see, there is a call to the service, and within the same page, there are calls to the service within the C# code portion. And here, depending on the number of elements we have in our list, we can integrate and create as many HTML rows as there are elements in the list. That is, the C# code is completely embedded into the HTML, which is what makes Blazor so powerful. In the same way, we have the page counter.razor, which is the code example we had already seen, where when the user clicks on increment count, this is an event that is defined in the Blazor code portion. There is a variable that is even defined within this code portion, but whose values can be easily used outside of that code and within the HTML. We also have some components here, but yeah, well, things that we will see in more detail in following videos. So this was just meant to be a general overview of what a Blazor application is and how it works. If you liked the video, please give it a thumbs up and please subscribe, because that's the only way I can keep making these videos. Thanks, and I will see you again soon.